So how was factoring? 6-2. Was 6-2 okay? Or do we need to do some 6-2s? What do you think? I handed out to you a sheet that had 6-2 stuff on it, so we can review a little bit here. And we can review a lot, because we're gonna, one of the sections today is putting all of what we've done for chapter 6 all together, and that's 6.5. So 6.5 has got a lot of problems in it as well. So last time in 6.2, what we had talked about in here was if you had pluses in here, remember we took the last number, the last piece, 36 in this case, and came up with two things that added to give me 15 in the middle. So 36 would end up being 12 and 3. They're both positives because 36 was positive at the tail end. And so if these are both positive, this is positive and the middle's positive, both of your values that you're going to put in are going to be positive. If you've got a negative and a positive in your trinomial, then you're going to have the end value as a positive 63 in this case, but I need things that add to give me a negative 16. When that happens, if this is positive, then both things over here have to be negatives to get the middle, okay? So your negative piece has to be what you work with those. This one, when you have a negative and a negative in there, that's going to mean that you have a negative and a plus, and the negative factor needs to be larger. So if we look at the example, a negative 2, x squared minus x minus 2, this is negative, so that means I have to have a negative and a positive, but because the middle is negative, I need to subtract those two actually and get x minus 2 and x plus 1 when I do that, okay? So for those, we've got to be careful and make sure we get those. And then the last one, and there's only 4 kinds of these. There's not any more. It's not like we have 6 of them or whatever. There's only 4. And the final one is if this last piece is negative and the middle is positive, that means the positive piece is to be the larger factor or the larger piece that's in there. So the middle term's positive. I know that last term has to be, or the positive term from that last value has to be that. So if I got a negative 20 and a positive 1, negative 20, I need to come up with factors that give me that. Oh, that would help. You're not seeing anything. There, now you are. So the video's videoing it, but you aren't seeing it. Sorry about that. I forgot I had that turned on. You should have said something earlier. Okay, that's great. Okay, now you can see it. Sorry about that. So now I went through all that, and you're like, huh? Where's she pointing at? What's going on? Because mine was up here, but it just wasn't shown there. So back on this, that we learned last time, I had a negative 20 and a positive 1. I needed factors of 20, or things that multiply to give me a negative 20, that added to give me 1 in the middle. So those happen to be 4 and 5. And so that ends up being what my 2 pieces are that I put in here. But because that middle is positive, my positive factor needs to be the bigger piece. So it needs to be the bigger section or the bigger one that I possibly have with that. Okay? So we need more of those. What do you guys think? More? No more? Got it down? What we got to do? It's all in what happens with this. That was that extra credit sheet that I handed out to you guys too, that had that whole piece and pulling those things together and saying what multiplies to give me this middle term. And so we have to do that. We have to get that part in place with those. So that's my part with this one. So then if I go down here at the bottom, 6.3 is that we need to come up with the stuff, and we went through this whole process in 6.3. In 6.3, we multiplied the first term of our binomial times the last term. So if I've got x squared minus 22x plus 5 is my trinomial, and I want to come up with what my value is, I'm going to multiply 8x squared times a positive 5. And that gives me 40x squared. We good there? Okay. Then the middle piece, it says find the factors of part 1 to create the middle term. So watch signs. So it was a positive 40x squared, but it has to add to a negative 22x in the center. So factors of 40, 1 and 40, 2 and 20, and so forth. But I find that a negative 20x and a negative 2x does indeed equal a positive 40x squared. And at the same time, a negative 20x and a negative 2x equaled that 22 at the tail end. So I ended up getting my negative 22. There should be a negative sign in front of there. My negative 22x. Then we replace the middle of the trinomial with the values from step 2. So I pulled out that middle of the negative 22 and stuck those in the middle. We good there? And then factored. It says factor by grouping from 6 1. So I put them in groups of 2s. Pulled out a 4 out of the first, gave me this. Pulled out a negative 1 out of that, and gave me that. Now these have to match. If they match, we're good. If they don't match, we're not good. Okay? So make sure that the two of those things match and that they're identical to each other. So when I pull this out, I get a 4x, and I pull that out, I get a negative 1, so then I get this piece, and then finally check it. 4x times 2x is 8x squared. 4 times a negative 5 is negative 20. 1 times 2x is a negative 2x. Negative 1 times 5 is a negative, or is a positive 5. So I'm right back where I started at. Okay, so that's a review. So it's pulling all these things together. So we've got all of those statements and all that stuff in there. Yay or nay? Okay, and in 6.5, we'll go through and do some of these. So we're going to look at that section, and we'll have some of these things to do. So we'll pull it all back there too, as well. Okay, and in 6.4, we're going to have some stuff in there too that's going to let us work with some factoring too. So we're still going to have some factoring stuff. So it's not like we're just going to leave it at this point and not have anything else that's going on with that. So, we ready for 6.4, you think? Okay, 6.4 is broken into 2 pieces. One piece has special factoring, and that's 6.4a. So, let me get 6.4a up here. And in 6.4a, we have difference of squares. And difference of squares, what this is going to mean is that we have a square at the beginning and we have a perfect square root at the tail end. So we've got things that look like x squared minus 16. And because it's perfect squares at each end, and if I know this, and we talked about this last time in chapter 5, I was telling you, you've got to reverse some of these things. So we get an x and an x, because it's a single x squared out in front. Factors of a negative 16 means one's going to be negative and one's going to be positive. And I won't pick things like 2 and 8 because that's not perfect squares, because I'm looking for perfect square values. So 16 is 4 times 4, so I have a negative 4 and a positive 4. And so when I check this, x times x is x squared. X times plus 4 is a plus 4x. Negative 4 times x is a negative 4x. And a negative 4 times a positive 4 is a negative 16. But what happens to my middles back from chapter 5? The middle part disappeared. And so I didn't have it. Okay? So the middle piece in there was not in my values, okay? So it cancels out. We use this a lot in intermediate algebra. If you ever, when you get to intermediate, if you take intermediate, we've got some combinations of stuff in there, and so we get some things happening with that part that are in place as well. And so we're going to look at this, and we come up with what's called the conjugate. And the conjugate, they might give us this one, but its conjugate is this piece that causes the middle terms to disappear. And we use it quite often in there in a variety of places. So it's kind of building you up for that piece too. So throughout, I've been kind of telling you about intermediate algebra things as we go along with that. So what about this one? I guess I don't need my parenthesis in there. X squared minus 25. What does it factor to? X squared. Yep. Yep. Mm-hmm. And again, they have to be perfect squares when you're doing this. So if I have 9x to the 4th minus 16y squared, what are we going to get with this thing? Well, when we have even exponents like this 4 is 2 times 2. So when I break it apart down here, and I put it inside of my value, I'm going to have x squared and x squared. 9, being a perfect square, is 3 and 3. Are we good there? 3 times 3 is 9. X squared times x squared is x to the 4th. And what about this piece? Well, negative 16 is a minus 4 and a plus 4. And then y squared just means that I have a y at both ends. So there's a y in both of those spots. So that's what that one factors to. So that one's kind of a little different because it's got a lot of pieces to it. So if I check it, 3 times 3 is 9. X squared times x squared is x to the 4th. 3 times 4 is plus 12, x squared, y, because they just come along. And minus 12, x squared, y. And finally, negative 4 times a positive 4 is a negative 16. Y times y is y squared. So these cancel in the center, so I know I did it right. Okay, so my final answer is x to the 4th minus 16 y squared. So it works out the way it should. So I know I did it correctly because notice I came right back to where I started at. Okay, so it's the same thing. Questions with that piece? And the other neat thing about these is it's a binomial. It's a binomial to factor. So if you see a binomial, you're going to look for perfect squares within it. And as everything that we do, there is sometimes a number that we can pull out, such as if I had 27 x squared minus 12. So it doesn't look like perfect squares because if you look at 27 and 12, what number they have in common? What could I factor out? Back to 6.1. We looked at any of these and I could pull out I can't pull out 4 because 4 doesn't go in 27. Pull out a 3. 27 divided by 3 gives me 9, x squared. 12 divided by 3 leaves me with 4. So now this whole thing factors to 3x and 3x, 2 and 2, and one's minus and one's plus. So that becomes my factored answer. So you got a little of 6-1 along with 6-4. And so you got some combinations of factoring in there. So always, whenever you do these, always look at them and see what you can pull out, okay, before you ever factor them. Because you got to watch and make sure that you get your perfect squares in those. So you think you're okay with that one? Yeah? Okay. Because we can still do some more if you're not okay with it. Now, word of caution. Cannot factor a perfect square binomial if the two terms are added. So if I had 49x squared plus 64, I cannot factor this. Is not factorable. And let me show you why. Because it looks like now I'm tootling along and I'm looking at all my stuff and I say, oh, 49. Yeah, 49 is 7x and 7x. Perfect. 64 is 8 and 8. Great. I can break it down. I got it going. I've got doing some stuff with it. But as soon as I get a plus sign here, what happens? What do I have to give me 64? What signs would I put in there? Right, a positive and a positive, or, but what happens if I check it? 7x times 7x is 49x squared. Perfect. 7 times 8 is plus 56x. 8 times 7 is another plus 56x. 8 times 8 is 64. But what do I notice on those two middle terms? No, that's right. They do not. They do not cancel each other out. So therefore, I get a middle term, and I can't have a middle term. I can't have a middle term, so I want to make sure that that does not happen. I didn't have a middle term to start with, and I've got one now, so I cannot factor this. Okay, the same thing would happen with the negatives, because it would just be a negative 56 and a negative 56. So you've got to be real careful and watch if there's a plus sign between them. It cannot be factored. And so just remember that can't do pluses, can do all kinds of minuses, because if this one had been 49x squared minus 64, we are really good to go. Okay, because with that one, we would have 7x and 7x. minus 8 and plus 8, so we're good there, okay? But not with a plus sign. So if you run across those, they're not factorable. Usually, somehow, somewhere down the line, you'll make a mistake, but if you always check them, you won't, okay? And because if you're checking it, it's not going to show up as a mistake in there, okay? Questions with these at all? Or we think we're okay? Hopefully, we're good. So then, the other piece that they have with perfect squares with this and the special ones is where you have a perfect square on each end. So we got x squared, and you have a middle term. So these are going to be trinomials. So they're a trinomial. And what happens with these, so they're trinomial with perfect squares on each end that multiplied add to the middle term. So we are going to go through and we're going to make sure we check them so that they do. So if I look at this, perfect square there, because x squared is x and x. Perfect square on the last end, 16 is 4 and 4. My middle term is positive, so that means maybe those should both be positives in there. So x times x is x squared. 4x, another 4x, finally a 16. So those two added, x squared plus 8x plus 16 does equal what I started with. Okay, so it does work out, and it does come out to be that value that we happen to have. Okay, yes, what do you think? Okay, they're either going to be plus or that one, for instance, which has a minus in it. And so if we take a look at it, we get x and an x. Factors of 9 are 3 and 3, but my middle term is negative, so that means I have a minus and the minus. Now, does it work? X times x is x squared, negative 3x, negative 3x, and a positive 9. So I get x minus 6x plus 9, which is what I started with. So this does factor to that. All right. Now, if you don't remember this, if you say, I don't remember anything about these perfect square stuff, I probably won't ever remember that these got perfect squares on the end. Can we do it the old way? The way we did it in 6.2? Sure. Because all I'm doing is looking for things that multiply to give me 9 and add to a negative 6. And it just so happens to be that it's a negative 3 times a negative 3. Okay? So a negative 3 plus a negative 3 does equal my negative 6. And so therefore, I know it's x minus 3 and x minus 3. So you can still use your old way. The only one you cannot use your old way on is that difference of squares, because you only have a binomial. But these, go back and use what we've been using. I mean, you don't have to remember about perfect squares. It just saves you a little bit of time. This answer could also have been written as x minus 3 squared, because they're identical to each other. And we had these back in chapter 5. So we had that stuff in chapter 5. And so that's where that happened to fall into and ended up being part of. So we can do those with that. How about this one? Get that out of the way. 9xy squared plus 12x squared y. No, this has got to be a cube out here. And plus 4 y. This has got to be just a plain old y. 4y cubed. I'll get it right yet. So let's see what we get out of this one. So what happens? What can I take out? Is there anything I can take out? A y. Can I take out anything else? Oh, this has to have an x. Now I can take out an x. If I didn't put an x, it wouldn't factor. So what am I left with? Numerically a 9. X cubed and an x leaves me an x squared. Y's are gone. X squared and x leaves an x. And it just needs to be a square on my y. Leaves me a y. And then finally at the end, 4. X cubed or y cubed, y leaves a y squared, and an x is gone. So can that be factored? They're nice if you know about perfect squares with this, because you don't have to do that long, drawn-out way of doing these. But if you don't realize that, you can still do it the longer way. But if you see a perfect square here and a perfect square at the tail end, try it. See if you can break it down. 4, what's 4's perfect square? 2 and a y. What's in the middle? Pluses. And don't forget your xy out front. Okay. And does it work? Do I really need to check this term and this term? 3x, it's going to be always 9x squared. This is always going to be 4x squared. The middle piece is the one I really got to check. 3 times 2 is 6xy. 3 times 2 is another 6xy, which is 12xy. So I'm good there. Okay. So it does work with what I have. Okay. So what do you think on these guys? You're okay? Now, once in a while, they will throw one in that you look at and you say, oh, I don't know if I can factor that or not. Let me find my one that I can't factor. this one. X squared minus 6x plus 4. Looks like it's perfect squares. Perfect squares here, perfect square there. That looks good. But can I get that negative 6 in the middle? So if I factor this, I get x and x. Looks like it should be a 2 and a 2. But it should be both minuses. But I can only get as high as a negative 4 for my middle. So this is not factorable. So I cannot factor it. So no way, no shape, no form can I factor it. Okay? So I can't factor it. So that's the piece I need to be careful with. So once in a while I can't do any factoring with those. Okay or not okay? Okay. And sometimes they do this to them. 8 minus 8x plus 2x squared. It kind of looks a little backwards. Can you pull anything out of it? First thing you want to ask yourself. And then from there you want to see if you can factor it. So does that factor? So it's kind of backwards because your number's out in front and your letters at the end. What signs go in the middle? Addition signs or subtraction? 2 subtractions, yep. 2 negatives go in the middle. Check it, see if it works. 2 times 2 is 4. 2 times x is a minus 2x, another minus 2x, and finally a plus x squared. And then last, multiply by 2 and get back to your 8 minus 8x plus 2x squared. And so you're right back to where we started at. So we did do it right. So what I would enter into Hawks is that for my answer. Yes?
You just turned it around.
Sure, you could turn it around. Yeah, it should. I know, it just feels foreign that way. Feels like it's kind of odd that we got some backward stuff going on in there. But again, it's what you do as far as reversing it and coming up with it of what they happen to have. And here's a really different looking one, and I'm thinking we got rid of these, but I want to make sure I have it in here just in case we didn't. X squared plus 8x plus 16 minus y squared. It's kind of putting both things together. So what I would have to do is first factor this first part. So what does that factor to? So it factors to x plus 4 and x plus 4. We good there so far? Since these are identical, I can put it as a square. And then what happens is if we put, you could replace this or simply remember it's x plus 4, x plus 4. Y squared is a y and a y. One's minus, one's plus. And that's what it would factor to. So it's kind of strange because you've got this thing that's right in that location. So yes, yep, you need to bring it to this point. Yep, because it's not factored all the way right here. Because now it becomes a difference of squares. And so then I need to factor it all the way. Okay, I think we pulled all those out, but I just wanted to make sure it was in there, that you guys did have it in your notes so you can see what takes place with that one. Okay. Need more of those? Or do you think you're, yes?
I don't really collapsing it
and then expanding it. I know. It kind of like, why did they have to do such a thing? But I don't know exactly why the authors decided, but that's just saying it's breaking it into two parts. So you had to factor it first, then you had to factor it again to get your answer to it. Okay. You could also have at this point put u squared minus y squared. We talked about those a while back in this chapter, I think it was, where we put something in its place and we factored it then and then we put it back in. You could do the same here and put u minus y and u plus y, then replace u with x plus 4, okay? And you get exactly the same results, okay? So you could replace it with a u.
Are they going to be certain step problems like that?
I think we pulled them all out. I just didn't know if there was one that was left in there, okay?
I mean, like, are they going to be like certain step problems where you have to do a portion like that, like collapse it?
Yeah, no, that's the reason I said that. I think these were all removed with your factoring out of there, but there might be one that sneaks in there, so I wanted you to have one in your notes that did that, so that you had one that you could look at, that you knew what it was doing and that stuff. So, yeah. But I think they're all out of there. I don't think there's any that remain. And then again, you might be the one who gets 20 of them. No. You know, I don't know. It randomly generates what you get. So sometimes stuff sneaks back in and that kind of stuff. Okay, you think you're okay with the specials? Specials, again, were differences of squares and then perfect squared trinomials that we dealt with. Okay, so section 6.4b is factoring cubes. So what are cubes? So let's go through and get our cubes down so we know what they happen to be. So when we see a number, we will know what it comes back to as a base. So in factoring cubes, we always have to get back to our base, so whatever our base happens to be. So if I take 1 and cube it, what am I going to end up with? 1. If I take 2 and cube it, what do I end up with? 8. And if I take 3 and cube it, 3 times 3 is 9 times 3 is 27. If I take 4 and cube it, 4 times 4 is 16. 16 times 4, I think that's good old 64, right? Put that on your calculator. 4 cubed is 64. I'm sure I'm probably right. 5 cubed is 5 times 5 is 25. 25 times 5 is 125. So we're good there, right? And 6 cubed, 6 times 6 is 36. And 36 times 6, 216, I think. Yeah. If you know those guys, you're pretty good. You probably will not run across anything else that we will see that's in these cubes. So that's our bases. Our bases are taking these numbers, which are the cubes, and turning them back into what our base values happen to be. So if you ran across 216, you would know it's 6 to the 3rd power. If you run across 27, and it'll make more sense when we do some of these, you will know it's 3 cubed. If you see 20 or 64 and you need the cube root and know what the base is going to be, it's going to be 4 to the 3rd power. Okay? So we've got to be able to reverse these. Now with letters or variables, our cubes and variables are x cubed, which is x times x times x. X to the 6th power is x squared times x squared times x squared. Basically, you're looking at multiples of 3 when you do these. X to the 9th is x cubed times x cubed times x cubed. X to the 12th is x to the 4th times x to the 4th times x to the 4th. And we found out that that's the type of stuff that we did back in chapter 5. 4 plus 4 plus 4 is 12. 3 plus 3 plus 3 is 9. 2 plus 2 plus 2 is 6. And 1 plus 1 plus 1 is 3. Okay, so that's our basis. So we got all of this base work that we have to work with cubes. Now the thing about cubes is they use a formula, always is a formula, and the formulas are not much difference from one to the other. It's just that we have two different pieces that we work with. So let me show you what those happen to be with our formulas. Now in Hawks, I don't like the way they do their formulas because they have x to the third power plus b to the third power, something on this order. And I don't like these because x is a variable we commonly see. We see it all the time. And so when you put that into this, it doesn't make you think you've got a big formula or think you have something that's really going to work. So I don't prefer that method. The one I like is a to the third power plus b to the third power, because what we're dealing with is our bases. So our bases that are cubes, like the 2 to the third power, the 3 to the third power, the 6 to the third power, all of those, the 6s, the 2, and the 3, were our bases in there. The formula with this is it's a plus b, the plus matches. So you got to match with the plus. So it matches the original without the cube. So it's going to match. Times a squared minus ab plus b squared. And again, a's and b's are bases, and this is the opposite of the original. So it's going to be the opposite of whatever it happens to be. So an example of this might be x to the third power plus 2 to the third power. Being that I've got my bases in there, so what this simply means is x is a and b is 2. So then all I need to do is plug those into my formula, and you just put them in place and you're done. So a is x plus b, which is 2, equals x squared minus x times 2 plus b squared at the end. Or x plus 2 is x squared minus 2x plus 2 squared, which is 4. And that's factored. That's as far as I can go with it. This trinomial will never ever factor. Okay? So that part won't ever factor. So we'll never end up getting that piece done and know what it's supposed to be. So it will not factor. This never does. And neither will the first part. It won't factor with what we have. Okay? Now this may have looked like x squared plus 8. Okay? Because 8 is a perfect cubed, which is 2 cubed. Whoops, that should be a cube. I can come up with my base. So anytime you have a cube in here, it has to go back to its base, because its base is what we use in our formula. So A and B are bases of cubes. So they're the bases of cubes. They're not the values that you happen to have. Okay? So let's do some more of these guys. So if I had 64 plus 8x cubed, what would my bases be? So I've got to first break it down to a base value. So what would be the base of 64? What times what times what gives me 64? That's identical. So it's 4 cubed. 8, what makes 8? 8 is 2 times 2 times 2, right? 2 cubed, x cubed. So what are my base pieces? So my base is 4 for the first. My base for the second is a combination. So it's going to be 2x. It's going to be 2 pieces that I happen to have. So once I get it broken down to my bases, I have my A and my B. Get this better here. My A and my B. And then I just plug it into my formula. But I have to get it broken down. I cannot just leave this piece as it is in order to work with it. So I've got to break it apart. So 64 was 4 to the third. 8 is 2 to the third. X is already to the third. But then I need to combine this piece. So 2 and x is to the third power. So 2x is B, 4 is A, and I plug them in. So first, it's A plus B. And if you write this formula every time you do one of these, and then it's A squared minus AB plus B squared, you'll remember what it is. Okay? So plug in my pieces. So I have 4 plus 2x. Second piece is 4 squared minus, because it's the opposite of A times B plus B squared. Yes or no? What are you guys thinking? Does it work or doesn't it work? Yes, no, maybe. Okay, so then to finish it, 4 squared is 16. And you can do this as you do these. You don't have to write it. If you want, write it out separate, then you don't make a mistake. 4 times 2 is 8x. And then finally square my 2x. 2 times 2 is 4, and x times x is x squared. And I'm done. Okay? And again, this will not factor. Now I could pull out a 2 out of that whole thing if I did that, but it's good for what we're doing with it, okay, for right now. Because basically up here we could have pulled an 8 out, and that's what would have made a difference in this piece. So I could have pulled an 8 out and still been left with 8 plus x cubed, and that would have been the thing I would have factored, but we're still good to go. Okay? All right. What do you think? Again, get it to bases. You got to get this piece broke down to what your bases would be in there. Okay? When you're working with it. Let's do another one. Oh, I'm going to flip it. Did I flip it? Okay. And so I'm going to first put my formula up here. So again, I need to remember it. So it's a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. Okay. Again, remember this matches. It's a plus. This is opposite. And then everything else is pluses. So what about this one? Find one that I got in my notes here. We can end up doing x to the 6th minus 125. Oh, let me put a plus in there. We haven't did minuses yet, but we can do it as a plus in it. It'll work the same way. And we'll do minuses in a minute. They're not any different, but the tough piece in this one is x to the 6th. It's an x squared. 6 is 2 times 3, so I get x squared. What's 25? 125? 5? Mm-hmm. Yep, so I know this is A, that's B, and all I need to do is stick them in the formula. So it's kind of a routine. It's got a pattern to it. So you always get down to bases, and then you plug them in. So I have x squared plus 5, because it matches. Then it's x squared squared minus x squared times 5 plus 5 squared. Yes, now we're going to go back through and simplify it. X squared plus 5. X squared times x squared is x to the 4th. X squared times 5 is a minus 5x squared. So that's when you can do that in your head if you want. It doesn't have to be that you write it out separately. It's just that if you do write it out separately, you're less apt to make a mistake. And then finally at the end, square 5 and get 25. And so that's your solution. So that's what I type into Hawks for my solution, right? So that's what it ended up being with that one. So those are pluses. If we take a look at this exact same one with a minus, we need a different formula. And our formula is still a cubed minus b cubed. And so if I follow my rules that I used on the first one, this one matched identical. So this is going to match identical. So it's a minus b. The formula is a squared opposite sign. So it started out as a minus. We're going to make it a plus. A times b. And finally, the tail part doesn't change. It's still b squared. And so basically in your formulas, it's identical. It's just whether you have a minus and a plus or you have a plus and a minus in your problem. So if I break this one down just like I did up above, it's x squared cubed minus 5 cubed. So I have a and I have b. And then it's just putting them in place. So it's x squared minus 5 this time because it's a subtraction. And then finally square it. X squared times x squared is x to the 4th. A times b, x squared times 5 is a plus 5x squared. And last, 5 squared is 25. And the only difference between this one and the previous one is my sign switched in the two pieces. Okay. This is probably the #1 spot where everybody starts making mistakes because you forget you got to change a sign or you forget what you need to do with them. But if you get that pattern down, that it matches, the first piece matches what your bases are. It's either plus if it starts out plus, or it's minus if it starts out with a subtraction in there. So your signs are what kind of messes things up sometimes. And then everything else, basically, it's still a, b, a squared, a times b, b squared. That stuff's the same. And basically down here is the same too. It's just these two signs that make the difference between them. So they're identical as far as everything else goes. It's just the signs are different within those. So let's see what happens with this one. 81 y cubed plus or minus 24x cubed. And it's all factoring things. We need to see if we can pull something out. Always look for a numerical value, a letter value, something on that order that we can pull out of there and do some other stuff with. So what could I pull out? Is there anything? 81 is not a perfect cube. 24 is not a perfect cube. So that should even give you an indication you got to do something with it. Okay? That it's not a cube. So we got to pull something out. So what's in common between 81 and 24? What number would be in common with those? What was that? 9? I can't pull 9 out of 24 though. So we're a little big. 9 comes out of 81, beautiful, but it won't come out of 24. So 9's probably too big. So what should we try? There's something else that might work. 81 and 24. 3, there we go. Yep, pull out a 3. 81 divided by 3 leaves me with 27, y cubed. 3 out of 24 leaves me with 8x cubed. So now once I got the 3 out, what do I have now? I got some perfect cubes going on here. Perfect cube for 27 is what? What's its base going to be? So 3 cubed, y cubed. What about 8? 8 is a perfect cube, so 8 is what? So it's 2 cubed, x cubed. So now I need to say 3y cubed minus 2x cubed. So I get my a and my b. Now it's a matter of plugging them in. So if I plug them in, I have 3y minus 2x, because they match, identical. Square my 3y, add a times b, so 3y times 2x, and finally square the 2x. So I have 3y minus 2x. 3y squared is 9y squared. 3 times 2 is 6xy. And last, 2 times 2 is 4x squared. And so don't forget your 3 that you pulled out originally, and you get your answer with that one. Okay, what do you think? No? Questions? Any questions? Questions of where I got what in here? Any ideas of where stuff came from? What we had to do? Originally started with this. So I needed to pull out a 3 out of here to get perfect cubes. Then I broke my bases down. 27 became 3 cubed. Y cubed is y cubed. 8 became 2 cubed. And x to the third become x to the third. Then my bases, because I got double cubes going on here, so I need to go 3y cubed minus 2x cubed. And then this was a, and this is b, so I plug them into my formula. But when you plug them in, it gets kind of messy because we've got 2 things that need to get squared or multiplied and whatever we got going in there. So 3y minus 2x, because it matches. It's going to be a subtraction, it matches. 3y squared plus 3y times 2x plus 2x squared. And we end up with what our solution happens to be. Okay? So that's what happens. Another one. Let's do another one, because I think I still get some ideas that it's not quite as clear as mud could be. So 54x cubed plus 128y cubed. Again, one of the large ones, so is there something I can pull out? Because 54 is not a perfect cube. 128 is not a perfect cube. So when you see that, you should know there's something I got to pull out. So what can I pull out of there? Well, they're even. So if they're even, we can at least pull out a 2. So let's see what happens. 2 out of 54 is 27x cubed. Plus 2 out of 128 is 64 y cubed. Okay, so far? And I got to get it all to cubes. So 27. So if I went back to when I gave you the cubes in here, what would they be? So I've got 27, and 27 is 3 cubed. $64 is 4 cubed. But again, they're not perfect in what we have there. So we have to go through and rearrange stuff. So I have 3x cubed plus 4y cubed, and now I have it where I can work with it. Again, Hawks is going to give you different formulas than what I just gave you. It's the same formula, it's just their lettering to me gets confusing because of putting X's in there and not making sure you have different letters that you're plugging stuff in for. And my formula was A plus B equals A squared, opposite sign, AB plus B squared for that part. Again, matches, opposite. So plug in A, plug in B, square A, so 3x times 3x is 9x squared, minus 3x times 4y is 12xy, and last of all, square B. So 4y times 4y is 16y squared, but I can't forget my 2, so I type into Hawks. That whole thing. So I can't forget my 2 out here. So I would need to plug it in and see what I end up with. But again, don't forget to break your bases to cubes so that you get them to work out what you happen to have with that. Okay? Need to do another one? Or are we good? What do you guys think? One more? I'll put one more up there and see if what you guys can do with it. So let's put, as I standardly put all cube stuff in there. That one. You guys work at it for a little bit and we'll see if we can come up with the same answer. So what you'd find with that one is you take a 3 out. You guys get a 3 out of it? Hopefully. That leaves you with the 125y cubed plus the 27 at the tail end. 125 is 5 cubed and a y cubed. 27 is 3 cubed. So I get my base of 5y cubed plus 3 cubed and plug my stuff in. So it's going to be a plus b times a squared minus ab plus b squared is my formula because I started out with addition. So I just plug my stuff in, square my 5y squared, multiply my 5y times 3, square my 3 at the tail end, and I've done, and I've got my answer, okay, that I would type in. All right, what do you think? Okay, hopefully, again, those two formulas that you need to know are a cubed plus b cubed is going to equal a plus b times a squared minus ab plus b squared. And if it's a cubed minus b cubed, it's a minus b times a squared plus ab plus b squared. When you see them together, there's not much difference. Still all a's and b's, and just right here, these are the two pieces that change in them. Otherwise, they're the same, okay? So that's those two parts. All right, let's take a break, and what I'm going to do while you guys take a break is I'm going to go into Hawks and find 6.5, and we'll just go through and do the Okay, this is 6.5, so let's see what we can do with some of these, if we can factor them. There's 37 questions in here, so it's kind of lengthy, but again, it's getting you to understand about factoring and what we do have to do with it. So the first problem they give me up here, so let's just kind of work these guys out and see what we can do with a few of them. X squared plus 9. What do you guys think? Can we factor it, or is it not factorable? It's a binomial, pardon? I can factor it? All right, let's go over here and see if we can. So we're going to go back up to my Ladybug. Can we do that? So it looks like we could do it, right? X and X. 9 is going to be a 3 and a 3, right? But as soon as I put a plus and a plus between there, because I got to have a plus, what's going to happen? I get 6x in the center, don't I? So really, if I go back here, I need to say that it's not factorable because I end up with stuff that's not good in there, right? So we're going to submit our answer and see if we're right. So I can't factor it. So how about this one? Can it be factored? Does that one look better? Oh. Problem 2 is 1 minus 9x squared. So can we do something with this thing? Back to my Ladybug. Does that factor? What do you think? Perfect squares on each end. We just talked about that today. And I know you guys haven't practiced this, but we got a 1 and a 1 and a 3x and a 3x. But because it's a minus in the middle, that means I have a minus and a plus. So does it work? 1 times 1 is 1. I get a negative 3x, or a positive 3x. I get a negative 3x. My middle disappears, and these two multiplied gives me that. So I can factor that one. So that one works out good. So then I would type that into my box, parentheses, and I would put 1 minus 3x. Now, does my order make a difference in here? What do you guys think? Or have you found out you can put them in any order? As long as your two binomials are good, you can put those in whatever order you want to put them in. So I could have put the minus 3x second and the plus 3x at the beginning, so we can get that one. Okay, so we're good. What about this one? Again, they're going to jumble up your stuff, so they're going to have multiple things going on in there. So what about this thing? What would you want to do with it? So whenever we see 4 things, what do you think? 4 things is 6.1c, and we can group in 2s when you do that one. So so if we go over here to Ladybug, because I wrote it down, we would group in 2s and factor out a b in the first. And what can I factor out in the second piece? Factor out a z. And if these two match, we know we did it right. Okay? So I'm not going to take the time to type that in into my practice, but we know what we did with it, so we can do that. Okay? That one's a cube, and we just did those today, so I think we're good there, don't you think? Or not? I guess we could probably put it down here. So problem 4, 1 plus 27x cubed. And it's a cube, so I need my bases. So 1 cubed plus 3x cubed. Once I get it there, I can plug it in. So I have 1 plus 3x times 1 squared minus, because it's the opposite, plus the b squared. And so my final answer is 1 plus 3x. 1 minus 3x plus 9x squared would be what I get. Okay? And we know we are using that formula again with it. So that's what I would get. Okay, I'm not going to type it in because I think we know we probably have it correct with that one. Again, I just want to get you an idea of what shows up in here. What about this thing? What would happen to it? Factorable, not factorable. Let's see what we can do with it. Again, put it on paper. So here it is on paper. So what method do we use? Okay, take a number out. 2, 5, 3. Nope. V squared V, no V, nope, can't take anything out of it. So we use 6, 3. 2V times 3 is 6V squared, and it's going to equal 5V. So multiply and add. So 2V times 3V and 2V plus 3V. Then what happens? Where do they go from there? Well, then I'd have to replace my middle. Group in twos. And first one I can pull out a 2, this is a V. A V gives me with V plus 1. Here I can pull out a 3. Leaves me with V plus 1. They match. So my answer is V plus 1 times 2V plus 3. Okay. What do you guys think of that one? That's again a review. That was 6.3. 4 was 6.4b. This one was 6.1c. This was 6.4a. And that top one was also 6.4a. So we know where they happen to be at. So let's go back to Hawks and see what the next one is. I'm going to skip it. Think you're good with that one? So again, it's just kind of reviewing these. This is 6.2, and you would just simply put an X and an X. So let's do that. We'll put parentheses in here. 2 sets of them. Well, maybe it won't let me. So we'd have X minus 5 and X plus 4. So we get that one factored. And that was a 6.2. So again, just checking in as you go through these, a 6.1c, grouping in twos. I think you're good there. Just again, I want to check and see what we've got. This one's already grouped for you, so you're going to pull it apart and factor it. We good with that one? We need to do that one. It's again common factors, so we're going to pull out a minus 9, and then we're going to have parenthesis x cubed. Get back in there. Plus, minus 3. And so we get that for our answer. Okay, getting the idea? And again, it just keeps going with more problems like that. And I think we're kind of hitting all of them that we've had. Again, another 6.1. Factoring out the 2. So it just kind of goes through and gives you more steps of which ones you happen to have. That's a long one. We go with that one, you think? 5x squared times 11 is what we would do to get 56. So it's going to be 55x and an x to replace it, and then you'd factor from there. Okay. Should I keep going, or you guys had enough? Think you had enough? Okay. Again, 37 of them, so gives you lots of stuff to practice with your factoring. So we'll stop this and get out of that piece. And we're going to stop our share. So I can turn this guy off.